NVMesh gives you full flexibility to select the hardware of your choice: standard off-the-shelf NICs, standard servers, and NVMe flash devices. This way, you can design the storage that works best for you to meet your cost, efficiency, and performance objectives. NVMesh provides more IOPS, higher bandwidth, and lower latency than any other solution on the market. NVMesh virtualizes NVMe flash devices to get maximum NVMe utilization. We abstract the capacity of your NVMe devices across your data center and create a pool of high-performance storage. From that pool, NVMesh creates virtual NVMe devices that can be spun up and utilized by any host at arbitrary size and protection level. Those virtual devices look and perform like a physical local device with very little latency. Your applications can use the virtual devices as raw block volumes or with a high-performance file system on top of it. The NVMesh architecture is divided into 3 software planes and has 4 essential software components that implement these planes. The management software maps nicely to the management plane. The control plane features the target software and TOMA, the topology manager. The data plane is entirely handled by our intelligent client block driver. Here is how the actual implementation works. The server on the left is an application server. The server on the right is a target server with an NVMe device. The servers are connected over a high-speed network. The topology manager and the target software run on the target server. The application server runs our client software. The connection between the client and the target is made through our RDDA protocol, which is similar to NVMe over Fabric, but with lower latency and no target-side CPU overhead. When the client block driver establishes a connection from the block driver to the NVMe drive, the management acts as a database, holding all definitions of the entire cluster and all logical volumes. Once the client has established the connection, it can directly send I/O to and from this device without impacting the CPU of the target server. As NVMesh does not use CPU, it doesn't matter how active clients are against a target. This allows NVMesh to be deployed in a converged architecture with full application performance predictability. NVMesh enables you to maximize performance and capacity utilization. If you put 4 terabytes NVMe devices in your servers, it means you can never use more than 4 terabytes of space for an application in any one given server. So companies tend to buy bigger drives. As a result, customers are reporting drive utilization as low as 15 to 25% across all drives. By sharing NVMe drives between application servers with NVMesh, you can aggregate drives into larger virtual volumes. So if you have multiple physical NVMe devices and each one is 4 terabytes, you can put 2 devices together and have an 8 terabyte virtual device. Pooling your NVMe devices gives you the highest utilization levels, as unused capacity can be distributed amongst all the logical volumes. On top of that, you get very high performance utilization rates because you can share IOPS. NVMesh also offers different data protection options. One option for high performance is to mirror drives, for example, in a RAID 10, which does a striped mirroring over multiple devices. If there is a failure of a device or an entire host, your data remains available and protected. The logical volume will stay up. NVMesh features 100% distributed block services, and as such provides roughly 100% linear scalability. Most vendors will cut off performance graphs at a certain number of nodes because performance of their solutions will stop scaling past a certain number of nodes due to inter-node communication. For NVMesh, that graph looks very different. As you add nodes, network bandwidth, and NVMe drives, we increase our performance capability, IOPS, and bandwidth. Because we are 100% distributed software-defined storage with no interclient communication and the very low overhead thanks to RDDA, we achieve near 100% linear scalability. As a result, NVMesh gives the highest performance per rack unit in the market. Benchmarks in the field have demonstrated performance up to 40 gigabytes per second and 9.5 million IOPS per unit. With our 100% linear scalability, this gives a staggering 1.6 terabytes per second and 380 million IOPS per rack. So all these characteristics combined is what makes NVMesh revolutionary. A 100% distributed system with near 100% efficiency and near 100% linear scalability.